Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for rotating an image by 90 degrees. Let's look at the problem description. We are given an n by n 2D matrix representing an image. We have to rotate that image by 90 degrees clockwise direction. And also we have to do that rotation in place. We should not allocate additional space to store the rotated image. Let's take a look at the example 1. So we have a 3 by 3 matrix and we have to rotate this matrix by 90 degrees. The first row becomes the last column, the last column becomes the last row becomes first column, and the first column becomes the first row. Okay, so this one we do not have to rotate. In the example 2, we have a 4 by 4 matrix. So in that we have to rotate the first row, last column, last row, first column, and then the inner part of the matrix we have to rotate. So this 2 by 2 matrix needs to be rotated 90 degree. Okay, so if you see here, 4 move to the place of 8, and 8 move to the place of 6, and 6 move to the place of 3, 3 move to the place of 4. Okay, and this matrix row and column size are same, and the size is ranging from 1 to 20, and the each element's value is ranging from -1000 to 1000. Let's look at the approach to solve this problem. We are given this 4 by 4 matrix, and we have to rotate this 90 degree in a clockwise direction. So when we do the 90 degree rotation, this first row becomes the last column, this last column becomes last row, this last row becomes first column, this first column becomes the first row. So if you see, the cells in the matrix are grouped as a layer. So this is an outer layer, and then in the next rotation we rotate these 4 elements. Basically the matrix is divided into multiple layers, so we have to rotate each layer at a time. To have a better understanding, let's look at other size matrix. Here we have a 4 by 4 matrix. In this case we have 2 layers, outer layer and inner layer. And in this case we have 5 by 5 matrix. We have 3 layers, but we do not have to rotate this layer. The layer which has less than 4 elements do not have to be rotated. Okay, so technically we have only 2 layers that needs to be rotated. In the case of 6 by 6 matrix, we have 3 layers. All the 3 needs to be rotated. Okay, so each time the cells in a particular layer is rotated 90 degree, then we go ahead and process the inner layer. So how do we compute the number of layers that needs to be rotated? If we divide the row length by 2, because here the row and column size are same, we can divide any of them by 2. We get the number of layers that needs to be rotated. In the case of 4 by 4 matrix, 4 divided by 2, 2 layers. In the case of 5 by 5, 5 divided by 2, we have 2. In the case of 6 by 6, 6 divided by 2, we get 3 layers. Okay, so at any so in order to rotate the matrix by 90 degree, first we need to compute the number of layers, and then we have to initialize the index of the top left cell and the bottom right cell present in that layer. Okay, that forms the boundary of this layer, and based on that we can do the shifting operation. Okay, so this is the start row and start column, and this is the end row and end column. Once the start row and end row and start column and end column is initialized, we have to compute the number of cells that needs to be traversed by subtracting the end column minus the start column. That will give the number of cells that needs to be traversed and shifted 90 degree to the other location. In this case, start column is 0 and the end column is 3. So we will have to traverse the cells in this row. In each iteration, we pick up one cell in this row and then shift. The cells in the target locations will in turn be shifted to a new location. So eventually the matrix will be 90 degree shifted. Okay, so this is for the layer 0. Once this shifting is done, then we have to pick up the inner layer and shift these 4 cells. So depending on the number of layers, we have to shift the cells in each layer. For example, in the case of this, we have to shift 3 layers of cells. So the approach is to divide the matrix as the layers of cells and rotate the cells in each layer. And we can note one thing: the number of columns and rows in the inner layer is 2 less than the row size of the outer layer and column size of the outer layer. Okay, and one more thing is the starting cell of each layer is located in the cells which are present diagonally. Okay, so in this, for this layer, the first cell is 0, 0. For the inner layer, it is 1, 1. Okay, then first thing we have to do is find the number of layers present in the matrix by dividing the row by 2. Then for each layer, compute the top left cell and the bottom right cell's index and use that as the boundary, like start row, start column, end column, end row. Okay, we have to initialize that, and then compute the number of cells that needs to be shifted in that start row and iterate over those cells and shift them to the appropriate place. Basically, we save the value present in this cell and shift this value to this and this value to this location and this value to this location, and finally that whatever the value stored in the temporary variable will be stored here. So all the values are shifted 90 degrees. Let's look at the flow chart. Input for this procedure is the matrix. First we have to compute the number of rows and columns of this matrix and then initialize the layer variable to 0 and initialize the layer count variable. So the layer count will contain the number of layers that needs to be shifted. So we can compute that by dividing the total number of rows by 2. Okay, so once this is done, next we enter the outer loop which process the cells layer by layer. Okay, so first we check whether the layer is less than layer count. If so, we enter the body, and there we compute the start row, start column, end row, end column, and the cell count variables for that particular layer. Okay, so the start row and start column is equal to that layer number. So basically the start cell always present in the location diagonally, and the end rows and end column is the total number of rows minus the current layer number plus 1. That is the location where the last element is present, and we initialize the variable I for iterating over the number of cells in a particular row of that layer, and the cell count will give us the total number of cells that needs to be traversed and shifted to a new location. Okay. Once these variables are initialized, then we enter the inner loop which runs cell count numbers. Okay. So each time it will save the current cell in a temporary variable, and it move the cell from the start column to the start row. And once that move is done, then we move from the end row to the start column, and from end column to the end row, and finally we restore the value stored in the temporary variable in the end column. Next we increment the index I so that the next cell will be processed, and if the I is greater than or equal to the cell count, then we break out of that loop and we go ahead and process the next layer. So if the layer is greater than or equal to layer count, then we break out of this loop, and finally we return the matrix. Let's move on to coding. First I assign the row size and column size of this matrix to the variables rows and columns. Then I compute the number of layers that needs to be rotated in this matrix by dividing the rows by 2. Then I am writing the for loop which rotates the cells layer by layer. This for loop performs layer count number of iteration. Each iteration I initialize the boundary cells index start row with the layer number and end row with the layer number, because the starting cell always present in the diagonal location of the matrix, and the end row and the end column is computed by subtracting the layer plus 1 from the number of rows and the layer plus 1 from the number of columns. These four variables provides the boundary of the current layer being processed, and then I compute the number of cells that needs to be shifted in a given row by subtracting the start column index from the end column index. Then I write the inner for loop which actually traverse the cell count number of cells in the start row. Each iteration I save the current cell's value in the temporary variable. So the current cell is present in the start row and start column plus ith column. Then I assign the value of the cell located at the ith row from the end row and in the start column to the current cell. Next, I assign the value of the cell located at the end row, ith column from the end column, to the cell located at the ith row from the end row and in the start column. Then I assign the value of the cell located at the ith row from the start row and end column to the cell located at end row ith column from the end column. Finally, I assign the value in the temp variable to the cell located at the ith row from the start row and the end column. Next, I am going to run the test cases. All the tests passed. Next, I am going to submit this program. Cool, this program is accepted. Next, I am going to do the code walkthrough with sample input. Let's do the code walkthrough for this input. So we have 3 by 3 matrix, and first we initialize the number of rows, columns and the layer count. So number of rows is 3, number of columns is 3, and the layer count is the rows divided by 2, which is 1. Okay. So in this picture we can see the number of layer that needs to be shifted is 1. This layer has only one element, so we don't have to rotate this layer. Okay. Next we enter the outer loop, which is rotating the cells layer by layer. Okay. So in each iteration we have to first initialize the index of the starting and ending cell of that layer. The top left corner cell is the starting cell, and the bottom right corner cell is the ending cell. These two cells indexes provides the boundary for the layer. Okay. And then we have to initialize the number of cells that needs to be shifted in that particular row in that layer. For the layer 0, the start row is 0 and start column is 0, and the end row and end column is number of rows minus layer plus 1. So in this case 3 minus 0 plus 1 equal to 2. So it is pointing to the bottom right cell. And the number of cells that needs to be shifted is end column minus the start column. So in this case 2 minus 0. So the total number of cells that needs to be shifted is 2. These two cells needs to be shifted. Next we are entering the inner loop. This loop performs cell count number of iteration, and in each iteration what we do is we save the value of the current cell in the temporary variable. So this value is assigned to a temporary variable, and then we shift this value to this location. So that's what this assignment statement is doing. So basically it moves the elements present in the end row minus I. In this case end row is 2, I is equal to 0. So the second row and the start column is 0. So 2 comma 0. So this value is assigned to the cell, this cell. Okay. So that's what the start row is 0. Start column plus I. Start column is also 0 and I is equal to 0. The value in this cell will be assigned to the current cell. Okay. Then the third assignment, this value will be assigned to this cell. In the fourth assignment, this cell's value will be assigned to this cell. In the fifth assignment, whatever the value present in the temp variable will be stored in this cell. So these four shells are 90-degree shifted. If you look at it, when we enter the loop 1, 3, 9, 7. When we leave this iteration, we see 1 is shifted 90-degree and 3 is shifted 90-degree and 9 is shifted 90-degree and 7 is shifted 90-degree. Okay, so this is iteration 0. Okay, this layer, we have to rotate one more cell in that layer. So in the iteration 1, I is equal to 1 and the value present in the current cell is stored in the temporary variable. So this statement assigns the current cell's value in the temporary variable, and this statement assign the value in this cell to the current cell. The third assignment statement move this value to this cell. The third assignment statement move this value to this cell. The fourth statement move the saved value to this cell. Now we are seeing the values are shifted 90 degrees. 2 is moved to this location, 6 is moved to this location, and 8 is moved to this location, and 4 is moved to this location. So now we have shifted this layer. Okay, so 741 852 963. Okay, then after processing the cell count number of elements, we break out of this inner loop and then we try to process a second layer, but in this case we have only one layer, so the outer loop also ends and we return the matrix which is shifted 90 degree. Okay, 741 852 963. So 741 852 963. So this is what the expected output is. Next, I'm going to do the time and space complexity analysis for this solution. Time complexity for this procedure is order of n times n. Let's take a look at the case 1. We have a matrix of size 3 by 3. So the row size is 3 and the total number of cells is 9. And in this matrix, the number of layers that needs to be shifted is 1. 3 divided by 2 gives us 1. And in this procedure, we perform a couple of assignment operations. So in order to do the time complexity analysis, we have to count the number of assignment operations performed in this loop. Okay. So for this input, in the layer 0, there are 2 cells needs to be shifted. So for each shifting, we need to perform these 5 assignment operations. So 2 times 5, 10. So for the matrix with 9 cells, we need to perform 10 assignment operations in order to rotate the matrix 90 degree. And for the case 2, we have 4 by 4 matrix and the total number of cells is 16 and the number of layers that needs to be shifted is 4 divided by 2 is 2. Okay, so the number of assignments operation done in layer 0 where we need to shift 3 cells. Okay, so 3 times 5, 15. And in the case of layer 1, we need to shift only one cell. So 1 times 5, 5. So the total number of assignments in this case is 20. So for the matrix with 16 cells, we have to do 20 assignment operations. So the time complexity is order of n times n. Space complexity is order of 1 because we are not allocating any additional space in order to rotate the matrix in this case. We are just using few variables, so we are not allocating any additional space with respect to the input size. So the space complexity is order of 1. Thanks for watching this video. Have a great day.